All right. So in terms of the data, this is a data set. This is a very popular data set, by the way. This data set is free, by the way. The author has made this data available. So this data is free and everybody can use this data set the way they want. The original intent of this paper that was published in 1996 in JAMA was slightly different than the purpose of the way that we are going to use this paper's data in this class. In the original data, it was used for causal inference. So there was a outcome variable and there was a exposure of primary interest, and they were basically interested in the association between the exposure of primary interest and the outcome variable. In this class, however, we are not interested in the primary exposure of interest. We are just interested about the outcome and how well we can predict the outcome, right? In that paper, there were 4 different outcomes. I'm not going to talk about 4 different outcomes. For the purposes of this class, I'm just going to focus on 2 different outcomes. So the first outcome I'm going to talk about is the length of study, which is the hospital stay, how many days the patient stayed in the hospital. And this was measured sort of continuously. And the second was death within 180 days. So within 3 months, whether the patient died within the intensive care unit. And this was a variable that was certainly binary, whether that person died within 180 days or not. You can simply download the data set, and for creating the analytic data, I have gone through the steps. These steps are not that important for the purposes of this class. I just kept all of this just to be transparent, how I made the analytic data based on the data, that raw data that I downloaded from the website. So basically what I have done is I have created the length of stay variable by subtracting one variable from another. That's not so important. I recoded some of the variables. Say for example, death was yes, no variable. I just recoded it to 1 and 0. And then I removed some unnecessary variables and I removed some of the problematic variables. And then I did some basic data cleaning, which basically means that I have done some renaming, recoding and stuff like that. To create, and I have created some of the factors and named the factors in the way that I want to. All right, and then I did some basic data exploration or the summary statistics that I can get out of the data. To do the summary statistic, obviously, first thing I want to check how many data points I have in my analytic data. I did not delete any data points, by the way, when I was creating the analytic data. So this was the entire data. I had over 5,000 data points there. And in terms of the variables, I in total have 52 variables. Within those 52 variables, 2 variables are outcome variables. One variable is the length of stay, one variable is the death, and another 50 variables I have as the covariates that I'm going to use to predict whatever outcome that I'm going to choose. All right. Okay. So in terms of summarizing the data, after you have prepared the analytic data, there are a couple of packages within R that can summarize the data pretty comprehensively. One of those packages is this scheme R package that I'm using. Basically, what I'm doing is that I'm just saying scheme and then analytic data within that. And this is going to give me a printout of the summary of what is happening in the data set. So you can see there are 5,000 data points, more than 5,000 data points, 52 variables. And then I have 32 of the variables are factor variables and 21 variable is the numeric variables that I have over here. So that gives you a general summary, and you can see a more detailed version of the summary where you can see, so for example, cancer was one variable. There was no missing values in the cancer variables. The completion rate was 100%. The data was not ordered. And some of the numbers that you see over there are summarized, the top counts. So this is basically the data that we are going to use. So the first table that I showed here are basically the factor variables that I'm going to use in the data set. And the second table I have here are basically the numeric variables. That is obviously, since we have a numeric variable, we get more summary, like we get the mean, standard deviation, and the percentiles in this same table. Obviously, the schema is not the only package. There are other RMS package that use the describe function to describe the data and stuff like that. So you can use all that, but this is generally to show that once you have created the analytic data. The analytic data creation takes a bit of a processing, and that requires some time. But after you prepare the analytic data, there are some nice packages within R that can directly give you the summaries of the dataset in a very straightforward fashion. In a predictive modeling context, all you are interested is the prediction of the one outcome that you have in the dataset, right? So say, for example, length of stay, if that is the outcome that you are interested in, all the other covariates that you have, you are using all of these powers to just predict that length of stay variable. So that is the example of a prediction modeling. In terms of causal modeling is slightly different, where of course you have the outcome variable and you want to use all of these covariates to predict your outcome, but that is not the only thing that is happening in that modeling. You also have a primary exposure of interest. Say, for example, this is a treatment. You just basically want to find out, if you give the treatment, what is the impact of that treatment on the length of stay, right? So you are basically interested about the relationship between two. All of these are basically background variable, some sort of confounding variable that you need to adjust to get the unbiased estimate between the association between the RHC and the outcome, the length of stay.